Welcome to problem 2. This is on week 4 or 5, depending on when we do this. Probability stats day 1. This is problem 2, giving you a list of data. And what's great about this one is we're going to see if we can take some real data and draw some conclusions about it. So the first things first, all members of a large athletic shot put competition are going to produce the following data. Now this is from 2016. And here's your 10 data points. As you're thinking about 10 data points, n is equal to 10, the degrees of freedom immediately you can calculate will be 10 minus 1 or 9. Then we're trying to look at last year's, the 2015, and we notice that the mean is 12.4 meters was our mean, and we are trying to see if there's a difference this year. So the way that we're going to do that is we're going to come up with a hypothesis. Mu is equal to 12.4. That's if nothing changes. And then for alternative, we're trying to say, hey, we think we've done better this 2016. That mu is significantly greater, or it's not statistically the same. All right, so do you have a reason why the t-test is used? Well, that's because your variance for 2015, not given. Since that's not given, then you would use the t-test. T-test is only for known mu, unknown variance. For the normal distribution, you'd need to know the variance and the mean. And the critical region for the test. So this is the part where we use a calculator, and you'll go to, believe, you go to second variance, which is the distribution part, go to inverse t, that's number 4. And then we're trying to look at 5%. That means at 95%, 0.95, the degrees of freedom of 9, you should be able to find out what that t-value is. So anything greater than 95 is going to be, t will be greater than 1.83. If you want to see it for 10%, you go inverse for second distribution, number 4. You go for 10% and higher, it'll be at the 0.90, and still at 9 degrees of freedom, and that's going to give you a little bit smaller value, 1.38. There you go. All right, so once you have that, now we have these two test t-values, but statistically, if you're looking for 90% confidence or 95% confidence, you have two t-values. Now we're going to take our data and go to the stat, put in the data in the edit part, and you'll have all 10 of those in there, and then you're going to go stat, calc, and go 1, the first one, 1 variable stats. One more time, you go stat, go to the middle one, calc, and then go to 1 variable stats. There's 10 individuals, there's not a pair. And then you go down to calculate, and when you hit calculate, it's going to give you a whole bunch of stuff. Now the whole bunch of stuff is what the mean is. The mean is 13.18, so that's something we needed to know, mu. And then you have a couple of standard deviations here. You have 1.53 and 1.45. For the unbiased estimate, the s of n minus 1, sum of x squareds over n minus sum of x quantity squared over n times n minus 1, that gives you this silly looking s of x, it looks like. That's the one that I want, 1.531. Going back to the problem, they said mu is 13.18. The variance is 1.531 squared. So make sure that you get that. Then we are almost in the home free on this one. Find the value of the test statistic. You need the formula for the t-value, x bar minus mu over sigma over the square root of n. This is the formula for finding the t-value, and then you just put those in. X bar is 13.18 minus mu. This 13.18 is from the 2016 data. This is from the 2015 mean, and the test statistic that we had for variance was, for standard deviation, was 1.531. That's what we had here. And going back, this was the variance squared, 1.531 squared. That's what they want. But for my formula, I only want sigma. So sigma is 1.531, not 1.531 squared, over the square root of n. And when I get that, I get the t-value for the 2016 data of 1.61. So that goes for C, part 2. And then the last part, state a conclusion that the president of the club could reach. So I'm looking at 10% or 90% confidence is 1.38, and 5% confidence or 95% confidence is 1.83. This is where my 2016 data t-value sits. So this gives me numerical rationale of why we can reject the null or accept it. We can reject the null at the 90% confidence. Excuse me. Yes, we can reject the null at the 90% because we're greater than 1.38. But we cannot reject the null at 95%. So since 1.61 is between these, we reject null at the 90%, and we fail to reject. Somebody told me you can't accept, you just fail to reject at 95%. And that is taking real data, using the t-value, t-test, and getting a result.